Have you ever wondered about the tiny powerhouses that fuel our modern world? Batteries are everywhere, from our phones to electric cars, silently storing and releasing energy. But how exactly are these remarkable devices made? And what makes them tick? Let's embark on a fascinating journey to uncover the secrets of batteries. Our story begins with the fundamental components of any battery. Every battery has three main parts: an anode, a cathode, and an electrolyte. The anode is the negative electrode, and the cathode is the positive electrode. These electrodes are made from different materials, chosen for their ability to react chemically. Between them lies the electrolyte, a substance that allows ions to flow but not electrons. This crucial separation prevents a short circuit and directs the electron flow. The manufacturing process starts by preparing the electrode materials. These materials are often mixed with binders and conductive additives. They are then coated onto thin metal foils, like copper for the anode and aluminum for the cathode. These coated foils are then cut into precise shapes and sizes. Next, the separator, a porous membrane, is placed between the anode and cathode. This separator prevents direct contact between the electrodes while allowing ion movement. These layers are then carefully stacked or wound together to form the cell assembly. The cell is then placed into a casing, which can be cylindrical, prismatic, or pouch-shaped. Finally, the electrolyte is injected into the casing, saturating the electrodes and separator. The cell is then sealed, and terminals are added to connect it to external circuits. Some batteries undergo a formation process, where they are charged and discharged slowly. This activates the materials and creates a stable layer on the electrodes. Now that we know how they're made, let's explore how batteries actually work. It all comes down to a chemical reaction called an electrochemical reaction. When a battery is connected to a device, a circuit is completed. At the anode, atoms release electrons and become positively charged ions. These electrons then travel through the external circuit, powering the device. Meanwhile, the positively charged ions move through the electrolyte towards the cathode. At the cathode, these ions combine with the electrons returning from the circuit. This process completes the chemical reaction, generating electricity. This flow of electrons from anode to cathode is what we call electric current. The battery continues to discharge until the chemical reactants are depleted. For rechargeable batteries, applying an external current reverses this process. Electrons are forced back to the anode, and ions return, restoring the battery's charge. This cycle of charging and discharging can be repeated many times. Batteries store energy in the chemical bonds of their constituent materials. When discharged, this chemical potential energy is converted into electrical energy. The amount of energy a battery can store depends on the materials used and its size. There are many different types of batteries, each with unique characteristics. Alkaline batteries, common in household devices, are non-rechargeable. Lead-acid batteries are robust and used in cars for starting engines. Nickel-cadmium and nickel-metal hydride batteries were early rechargeable options. Today, lithium-ion batteries dominate, powering most portable electronics and electric vehicles. They offer high energy density and a long cycle life, making them incredibly efficient. Other emerging types include solid-state batteries and flow batteries, promising future advancements. But who was the brilliant mind behind the first battery? The credit goes to Alessandro Volta, an Italian physicist. In 1800, Volta invented the voltaic pile, the first true electrical battery. His invention consisted of alternating discs of copper and zinc, separated by brine-soaked paper. This simple yet revolutionary device produced a steady electric current. Volta's discovery opened up entirely new fields of scientific research and technological development. It paved the way for countless innovations that have shaped our modern world. From Volta's humble pile to today's advanced lithium-ion cells, batteries have evolved dramatically. They continue to be a cornerstone of our electrified society, enabling portable power. Understanding their construction, operation, and history gives us a deeper appreciation. So, the next time you use a device powered by a battery, remember its incredible journey. From raw materials to complex chemical reactions, it's a marvel of engineering. Batteries truly are the unsung heroes, silently powering our daily lives. Their continuous evolution promises an even more electrified and sustainable future. Thank you for joining us on this enlightening exploration of batteries.